Hi guys, in this part of the signal introduction to signals, I will be talking about signal energy and power. Okay, in this video we will mainly focus on the energy concept and power concept. Okay, we always hear these kind of concepts in our daily lives. Okay, energy, uh, kilowatt hours, power, watt, kilowatt, joule, those kind of things we will be hearing a lot in our careers. So if we start talking about resistor, and this is my resistor, and I have it here, and a current I of t is flowing on it, and then I have a voltage V of t over this resistor. Okay, how do I find instantaneous power, anlık güç? How much power is dissipated, harcanmak? How much power is dissipated instantaneously on a resistor? Okay, if you remember from circuit theory, P is equal to V times I, or V can be or I can be written as V over R, then P will be equal to V square over R, okay, or I squared times R, okay. Now we will be focusing on this part. So the instantaneous power on a resistor will be equal to V square over R. So if you're talking about power, we have to take the square of the current or the voltage value that we have. If we are talking about total energy, arkadaşlar, total energy, it is coming from the power. It is like I am adding up all the instantaneous powers between a certain time instant until another time instant. Okay? So if we are talking about the power dissipated over a resistor, it will be like V square T over R. But if you're talking about total energy consumed on this resistor will be equal to the integration over T1 to T2, like the instantaneous power value here, okay? That's why energy is like kilowatt hour, but the power is kilowatt or watt, okay? Times hour will come from this one, delta dt. So it's like time, smaller time instants. I'm adding up all the power that is dissipated at very small time instants. Okay. So if you talk about average, arkadaşlar, if you talk about average, what is average? It is like the power dissipated between a certain time interval divided by the time interval that we have, which is like T2 minus T1. Okay, so if you're talking about average, we have to divide the energy, total energy, by the total amount of time that we have dissipated power. Okay, average energy is like dividing by the period, dividing by the duration of this let's say a current flowing over the resistor. Okay, I hope you got the main idea. We have instantaneous power, we have total energy, okay, and then we have average energy. You see, everything is related to each other. Instantaneous power, total energy, average energy. So we will use these in generic terms. This was like for the resistor to work, but now as in signals and systems, we will be talking about not voltage or current all the time, not power or average energy dissipated over a resistor, but we will be talking about power of a signal, energy, total energy of a signal over a certain period of time. So here is what we will be talking about, okay? So this is like my signal, okay? I will have such a signal. and I will want you to find out the total energy of the signal. So this is like the magnitude of a certain signal. If it is a complex signal, you have to take the magnitude of it. If it is like a real signal, we don't care this if this is like that or this is like that. Okay, for real signals, we don't care about these magnitude terms. But for the complex signals, like complex exponentials, e to the power j omega 0 t kind of signals, then we should be talking about the magnitude of that signal. So similarly, when we talk about the total energy over a signal over a certain period of time on discrete time signals, now we will have this arkadaşlar, easy. I will have 0 at 1 volt, at 2, this is 2 volts, again 2, 3 volts. What is the total energy here? I will add 1 plus 2 to the power 2 plus 1, this is again 1, 1, which is equal to 6. Okay, this will be my total energy. How did I do it? I take the signal, I take the square of it, and then add them up. This is like total energy. If I divide these quantities by the durations, okay, here, what is my duration? For example, this is my signal. What's my duration? From 0 to, let's say, 4 seconds, then I will divide by 4. Here, what's my duration? This is like N1, which is 0, N2, which is 2, like 2 minus 0, 2 minus 0 plus 1 will be equal to 3. Why plus 1 arkadaşlar? Because I have three time instant, 3 indices, 3 samples. That's why I have to increase it by 1. Okay, the number of values between 1 and 2. How many numbers do I have here? 2 minus 1 is equal to 1 plus 1. There are 2 numbers between 1 and 2. Okay, 1 and 2 included. So for average power arkadaşlar, we will be dividing everything. Let me say for average power, okay, I will write average power, divide by N2 minus N1 plus 1. Here, average not average power, average energy, average power, sorry, then I will divide by T2 minus T1, okay? So these are the concepts that we have, that we want to cover here. If we are talking about the power and energy over an infinite time interval, if I have, let's say, such a signal, and my signal is like infinitely long signal, okay, something like that, for example, infinitely long signal, then I should be careful about this, and then say like I should use the limit concept here. Then these t values, what was the total energy here from minus t1 to t2 x t square dt. This was my energy concept, okay, total energy concept. And then now if I say my signal is from minus infinity to plus infinity, then this will go to minus infinity to plus infinity. That will include all my signals, all my values in my signal. Similarly, this is equal to similar in discrete time signals. Okay, if we are trying to find out the energy, like this average stuff here, then we were dividing by the duration here, if you remember. Like this is the energy calculation, total energy calculation. This was only this one is like power. If we add everything, instantaneous power, if we add everything in this interval, it will be like total energy, and if we divide by the duration, it will be like average power or average energy. So we have to divide by 1/2t, and then if the sums or integrals do not converge, then the energy of such a signal is infinite. Okay, so we might have infinite powers, infinite energies in our calculations. So let me talk about one thing, and I will finish at this point. For example, when you think about the when you think about the energy over one period, okay, this is like my complex exponential signal. This was cosine omega 0 t plus j sine omega 0 t. If you remember arkadaşlar, this was something like this, okay? This is like omega 0, and I'm turning around this unit circle, and always my amplitude is going to be 1, okay? The magnitude of this complex exponential, periodic complex exponential, is always 1. So if I take the square of it, it is still 1, and it is always 1 with respect to 0 to t0. And if I take the integral, it will be like t from 0 to t0, and my energy over one period will be equal to t0. Okay. So for a complex exponential signal like this, the energy over one period will be equal to 0. If you talk about average power, arkadaşlar, average power, like why average power? Why power? Because now energy was like kilowatt hour. Now I'm dividing by the period hour. Now hours will go away, and I will have average power. Okay, that's why I'm not saying average energy, but average power. This is like the energy. If I divide by the amount of time that this signal was active, then if I take if I divide by the time, then I will only have average power. Okay, this was the period of a complex exponential signal, a periodic signal, and this was like t0. If I divide by the duration was t0 again, which was our fundamental period, right? Fundamental period. And then now if I divide by that, my average power will be equal to 1. Okay, so this is critical, and I want you to understand these topics: the average power, total energy, and instantaneous power kind of concepts. And in the class, we will perform certain calculations to find out the average power and total energy for different types of signals. Okay, that's all for this part, guys.